Okay, good morning class. So at this point we're looking at the examples only in these videos. We spoke about all your rules with regards to geometry, which is angles on the straight line, your parallel lines, angles in triangle, and all of those things, which is your 2D geometry, or angles or geometry of straight lines. We spoke about chords, diameters, radii, radius, diameters, okay, we would say that tangents, seconds, and so on. Secant, second, whatever. Then we spoke about theorem 1. Theorem 1, A, which has an asterisk. It's a proof theorem for an exam. It's worth 5 marks. We went through it and we proved the theorem. If you want to get the explanation of the theorem, you'll find it in the description box below. In that video, you'll find all the theorems that is required for paper 2 in grade 12. We spoke about 1b. 1b is the converse of 1a, which is the reverse, and that's on page 275. Okay. Right. We spoke about 1c as well. Alright. So now we're looking at example 1, and example 1 is on page on page 277. Oh, I didn't. And these examples are for exercise 9.1 on page 278. So let's go with this quickly. So as I've indicated, if you have a circle, okay, and you have those lengths equal, if that was x, y, and z, and O is normally the center of the circle, then we can conclude, then OY is perpendicular to XZ. And the reason I said we're going to use this bisector from center to chord. Okay. Why am I showing you this one? Is because if you look at this diagram, you see there that those lengths are equal. So if those lengths are equal, we know that D1 and D2 is going to be 90 degrees apiece. You all understand? So when we prove the theorem, if this question would read, you are given that, you are required to prove that AM is equal to MB. So this is the only time we're going to prove the theorem, if they ask us to prove the theorem. Otherwise, we are just going to use the theorem and we're going to use that to be our reason in that case. You all okay with that? Yes, sir. Alright, so let's go back. So it says, given that AB is a chord of circle center O, so there is a center. D is the midpoint of AB. OA and DO are joined, which is that line. OA is 10, AB is 16. You mean to say the whole length is 16. Calculate the length of OD. How do you think you're going to calculate the length of OD? By using Pythagoras. For a Pythagoras theorem, to apply the rules of Pythagoras, what do I need? I need a 90 degree angle. Not so? So we'll start off by saying that D1 is 90 degrees. Why is D1 90? Because, I just told you now, bisector from center to chord. Okay. So there you got your 90. But what is AD? Of 16, which is 8. So AD is equal to 8. So AD is equal to 8. Why is AD equal to 8? Because that's given that AD is equal to DB. Did I have to write this here? What do you think? Did I have to write this here? Why must you write it? Was it given on the diagram? So now you must remember, if something is not given on the diagram, it must be stated. I can't just use 8. Okay? There is no 8 on the diagram. You guys understand? So if something is not on the diagram, it must be stated. Okay? That is how geometry works. So people are going to lose a lot of marks. You can get that answer, we can see already the answer is 6. And then you get no marks for it. Okay? So in geometry is all about logic and your layout of your work. Okay? So now can I apply Pythagoras? Yes. So what do I say? OD squared is equal to 10 squared minus 8 squared. Or I can say 10 squared is equal to 8 squared plus OD squared. Not so. And the reason here is, what am I using here? Pythagoras. With angle D1 equals 90 degrees. Can you see that, people? So now how do we get OD on its own? Take that over. So OD squared is equal to 100 minus 64, which is 36. The square root of 36? 6 centimeters. Can you see that, people? And that's how you get 5 marks for that side. Okay? So you must lay it out nicely. Any confusion there? So do it again. No? Okay. Let's look at example 2, and example 2 is on page 70. Also on 77. Example 2 is on page 77. Okay. We are told that PQ is a chord of circle center. So PQ is a chord of circle center. Okay. Radius OS is perpendicular to PQ. Okay, so now what do I see here? The perpendicular one that I just showed you now earlier on. Not so. So now we got the circle. There's your origin. There's 90 degrees. If that is PQR, then what can we conclude? Then PQ is equal to QRY, perpendicular from center to chord. Okay, that is your reason there. The reason for your theorem. Sorry? PQ, QR. Is that right? So you want me to say QP and no, this is not the diagram. This is what I made. I would have used ABC, whatever, it doesn't matter. Alright. Is there any confusion at this point? No. Okay. So now we are told that's 90. So automatically PR is equal to RQ. Okay. Then we are told that PQ at R and cut PQ at R. Then a radius OQ. Radius OQ is 25. Now what is the length of that line? Also 25. Why is that 25? Girlfriend, are you making notes of this on your phone now? Huh? Are you sending messages? Now what you're making notes on your phone? Don't lie to me, Michael. Put the phone away, please. So why is O is also 25? Your radius, not so. So if I'm going to use OS to be 25, I must state it's your radius. Why? Because that wasn't given as 25 to us. You guys understand? So whatever is not given to us, we must state it. Okay. PQ is 48. Okay. Remember that's half, so that's going to be 24 if needed. Okay. Probably will. And then calculate the length of SR, which is this here. But what can I calculate first using Pythagoras? I can calculate OR. Once I got OR, I take 25 minus OR, I will get SR. Or is. Will you guys understand? See any confusion? Right, so where do we start? Where are we going to start? What? We're going to say that RQ is equal to PR, which is equal to 24. Why? Why is that 24? It's not given. Why is those two 24? I just told you earlier on the theorem. What's the theorem? Bisector from center to chord. Okay. You bisect it from center to... No, not bisect. What is in your diagram? 90 degrees is in your diagram. So what are you supposed to write here? Perpendicular from center to chord. Did I say earlier on bisector from center to chord? When I draw this, the circle here? No. No, okay. I almost thought I made a mistake. Okay, so that normally goes next to here, no? Why is it not next to? No space, okay. Right, you guys are getting it, I think. Alright, so what do we say now? Can we apply Pythagoras as it stands there? Why not? Okay, can I calculate OR at this point? Yes, I got enough information. So what do I say? OR squared is equal to 25 squared minus 24 squared. Why? Because of Pythagoras with angle R2 equals 90 degrees. Or you could have said 25 squared is equal to 24 squared plus OR squared. Okay. So 25 squared minus 24 squared is equal to 49. And the square root of 49 is 7. 7 units. Okay. But have I answered the question? So now we know that SR is going to be 25. So we say SR is going to be 25 minus 7. And what's the reason that this is 25? Because it's your radius. And what is 25 minus 7? 18. So it's going to be 18 minutes. Okay. People, any confusion there? No. Now you go to exercise 9.1 on page 278. You're going to do every alternate sum for me quickly, okay? I'll check your books row by row now. In the description box, you'll find now the link to the theorem, the proof of the theorem, as well as last year's video or last year's lesson. Each and every odd number in this exercise and in the whole chapter is done in that in those videos. Okay, it's done comprehensively last year. Okay, this year I'm going to check your books more often. Okay. So if you have a problem, you can refer to the video in the description box below.